everyone. This video is about coordinate geometry paper 1 past paper questions. So example 1, here we have the point M is the midpoint of the line joining the points this and that. Find the equation through M parallel to the line. So we can find the midpoint first using the midpoint formula. Exactly in the middle between 3 and -1, exactly in the middle between 7 and 1, we get the midpoint. And then we can find the gradient by rearranging this equation here. We can just multiply both sides by 6. We get rid of the denominators. 6 times x over 3 is 2. 6 times y over 2 it's 3y. 1 times 6 is 6. And then we can subtract 2x from both sides. And then we can divide throughout by 3, so we get the gradient of this line. Now it says we are looking for a line which is parallel. Now parallel means same gradient, so for the line we are looking for, we know the gradient now, and we know that it passes through M, so the line passes through the 1, 4. Now we use the y minus y1 formula. For the points we use 1, 4, the gradient minus 2/3, and now we expand minus 2/3 times x minus 2/3 times -1, and then we add 4 to both sides, and then we simplify using a calculator. 2/3 plus 4 is 14/3, so this is the final answer. Next example, we have 2 points A and B, coordinates this and that, and BC is perpendicular to AB, intersects the x-axis at C. Find the equation BC and the x-coordinate of C. So to find the equation BC, it says perpendicular to AB, so we can find the gradient of AB using this formula, delta y over delta x. We find the gradient of AB, and since BC is perpendicular, we use -1 over, we get the gradient of the BC line. And because you see this is BC, so the line is passing through the point B, so we have the gradient and it's passing through the point B. We know the point B, so we use the y minus y1 formula here. We get this equation. This is the equation BC using the y minus y1 formula. And then we need to find the x-coordinate of C. So it says the C is the x-intercept, because intersects the x-axis, and x-intercept means because it's on the x-axis, it's gotta be something 0. The y must be 0. So we use this equation, but we replace the y with 0, and then we solve for x. We get the x-intercept. So this is the x-coordinate of point C. Find the distance AC. Well, we have the point A, and we have the point C. The C is 60. So yeah, you can find the distance using the distance formula. The difference in x values, difference in y values, square at square root. So we get this using the calculator in 3dp. According to the instruction, we have to use 3 decimal places. Now we have 2 points with coordinates this and that. The perpendicular bisector of AB intersects. So okay, let's just find the perpendicular bisector equation. We have the points 1, 3, 9, -1, and we can find the midpoint using the midpoint formula. We can find the gradient of the green line here, the gradient of AB, and the gradient of the perpendicular line is -1 over that. So we have the gradient of the perpendicular bisector, and we know that it passes through the midpoint, which means we can find the equation of the perpendicular bisector using the y minus y1 formula. After we find the equation, now it says we have to find the coordinates of C, and C is when it intersects the y-axis, the y-intercept. Now y-intercept is of course 0 comma something, so the x must be 0. We simply replace this x with 0, find the y value, and therefore we get the coordinates of C, which is 0, minus 9. Now we have points A and B, coordinates this and that. The equation of the perpendicular bisector is this. Find the values of the constants h and k. So this is the point HH, and for h plus 6, 5h, we can find the midpoint. We use the midpoint formula. Although it is in h, we can still just do the algebra and get the midpoint in terms of h. And now we can find the gradient also in h using the gradient formula. We can find the gradient in h, and we know that it's perpendicular bisector, so we do minus 1 over. So we do minus 1 over, we get the gradient of the perpendicular bisector. And now it's given the equation of the perpendicular bisector is this. So we can rearrange the equation of the perpendicular bisector here. So this is the equation given in the question, but we can rearrange to get this form so that we can see the gradient. Now the gradient is minus 3 over 2, but here we also get the gradient in terms of h. So since they must be the same, we just equate them and cross multiply and do the algebra until we get the h value. Now that we have the h value, of course we can find the midpoint, because the midpoint here is in terms of h. We know the h, you can find the midpoint coordinates, and after we find the midpoint coordinates, we can find the k, because we can just use the line equation, and we know that this point is on the line. We replace the x and the y, we get the value of k. Alright, I'll see you again next time for these examples. We don't have time anymore, so next time.